We'll now look at an example for theoretical probability. One card is selected from a standard deck. Find the probability that the card selected is, and part A asks us to find the probability that the selected card is an 8. So remember that our probability formula asks us to find the number of outcomes that are favorable to the event and divide by the total number of possible outcomes. In a standard deck of cards, there are 52 different cards, and so the denominator of our fraction will be 52. Our numerator is the number of outcomes that are favorable to the event. In other words, the number of outcomes that are 8s in this case. And so we'll look at our deck of cards and we'll ask ourselves how many 8s are in the deck. And we can see that there are 4 8s in the deck. And so we'll place a 4 on the top part of the fraction. We do want to reduce our fraction, and so 4 divided by 52 in reduced form is 1 out of 13. And so the probability of drawing an 8 is 1 out of 13. Part B asks us to find the probability that the card we draw is not an 8. And so again, the denominator of our fraction will be 52 because there are 52 cards in the deck. For the numerator, we must consider how many of those cards are not 8s. If there are 4 8s in the deck, then not an 8 is going to include everything else. So in other words, we want to exclude the 8s and count the remaining cards. And so if there are 52 cards and we have excluded 4, then there are 48 cards, 52 minus 4, that are not 8s. So 48 out of 52 is our answer. We do need to reduce that fraction, and that fraction reduces to 12 over 13. Part C of our example asks us to find the probability that the selected card is a club. So again, there are 52 cards in the deck, and so when we set up our fraction, we know that 52 will go in the denominator. For the numerator of the fraction, we need to count the number of clubs that are in the deck. And so if we look at our picture, we can see that this row lists all the clubs. And so there are 13 cards that I circled. So there are 13 clubs in the deck out of a total of 52 cards. Reducing that fraction becomes 1 out of 4. For part D, we're asked to find the probability that the card is a jack, a queen, or a king. And sometimes these cards are called picture cards. Sometimes they are called face cards. So again, there are 52 cards in the deck, and so the denominator of our fraction will be 52. And then we need to count the number of cards that meet the criteria that we're being asked about. So how many jacks are in the deck, and how many queens, and how many kings? And so if we look at those, we're talking about these cards right here. And so we can see that there are 12 cards that are either jacks or kings or queens. And so our probability will be 12 out of 52, which will reduce to 3 out of 13. Part E of the problem asks us for the probability that the card is a heart and a spade. And we want to pay special attention to the word and. and means that both events have to occur. So we want to know what is the probability that we pick a card and that card has a heart and a spade on it. Since it is not possible to select a card that has both a heart and a spade on it at the same time, then the numerator of our fraction will be 0 because there are 0 outcomes that are favorable. The denominator will remain 52 because there are 52 cards in the deck. And 0 divided by 52 is equal to 0. Saying the probability is 0 is basically saying that the event asked for is not possible. Part F is also an AND problem. We want to know the probability that the card is both greater than 5 and less than 9. And again, we want to ask ourselves, is it possible that we would have a card that is greater than 5 and less than 9 at the same time? So we are talking about the cards that have 6s, 7s, and 8s. So let's look at those cards. These are the cards that are greater than 5 and less than 9. And so how many cards are favorable? If we count the number of cards that we circled, we see that there are 12 cards that are favorable. And again, the entire deck of cards has 52 cards. So our probability is 12 out of 52, which reduces to 3 out of 13.